Okay, so welcome to the 21st class of our computer architecture and organization. So in this class, we are going to discuss about the concept of memory addressing modes. Okay, so I think we have already discussed the concept of memory addressing or addressing modes in our second unit, isn't it? So in our second unit, we have discussed the concept of addressing modes. Now in this unit, we are going to discuss about memory addressing modes. Okay, here there is a these are also one type of addressing modes, but there is a little bit of difference. That means here we will discuss the addressing modes which are related to memory only. Okay, we are not going to discuss much about immediate or something like that. We are going to discuss only about the addressing modes that are related to memory. That means either we are taking the data from the memory or we are transferring the data from the memory. That only we are going to discuss in this particular class. Okay, so coming to our topic, memory addressing modes. Okay, here we will come across two new terms. One is effective address and the other one is uh, signed offset address. Effective address and the effective address. Here this is the new name. Okay, here it is the effective address will come after the addition of two different terms. One is signed offset address and another one is base register. So after adding these two values, base register value and signed offset value, we are going to get a new value that will be referred as effective address. Okay, don't bother much. After one or two slides, we'll get an what you call diagrammatical explanation of all these topics. Okay, so no, don't bother about this. Okay, so here we will discuss about what is meant by effective address and what are these things. Okay, so in the memory addressing mode, if you observe carefully, see here there are two important. See, whenever the memory topic comes, you will come across two important instructions. One is load and the other one is store. Just given the example previously also. Loading is nothing but you are just taking the data from the memory and you are transferring that data from the memory to some register. Okay, storing means transferring of the data from a register into a memory location. It is just like what you will call shifting your house. Okay, whenever you want to shift your home from one place to another, what is the initial thing you used to do? First of all, you used to load all the luggage into a transportation lorry or transportation whatever auto. Okay, depends upon the amount of quantity of the luggage you have. Okay, so that will be referred as load operation, and the other one is stored operation. Storing is nothing but, see, for example, if I am shifting my home to from Guntur to Tenali, then what I am going to do initially, I will load all my luggage into that is present in my home into a lorry. I will, okay, so that phenomena is called loading because I am loading a lorry with the luggage. Okay, so it is called load operation, and that particular luggage will travel along with that lorry into up to Tenali. Okay, it will reach my new home at Tenali. Okay, once it reaches my new home, what is the thing I used to do? I will take all that luggage from that particular lorry and I will place in my new home. Okay, so it is called storing, isn't it or not? The house is used for storage purpose, so that is called storing operation. Here also we are having two important operations called load and store, but here the way of representing those load and store operations are different from those operations what we have seen, from those load and store operations what we have seen in the second unit. Okay, now we are going to see those differences. See here, LDR. So for load operation we use syntax LDR. Okay, so one second. Here if you observe carefully, LDR is there na? So this LDR is the syntax to perform the load operation. This is the syntax to perform the load operation. Okay, so whenever I write like this, LDR RD comma RN comma hash offset. Okay, what is the thing that is going to happen means, first of all, here hash indicates it is an immediate value. Hash indicates it is an immediate value. That means it may be something like 10, 12, 15, 5, like some value. Okay, now RN is a register. Okay, as we have discussed previously, register is nothing but group of flip-flops, isn't it or not? And registers are used to store the data. Registers are used to store the data. So registers are nothing but group of flip-flops. A flip-flop is a single bit binary data storage device. Okay, isn't it or not? So I think there is a blur. Okay. So what I'm trying to say is, see, whenever, see, load. What is the syntax for a load is load space destination comma source. Load space. One second, right? And wait. Text. Yeah. The syntax for load operation is load space destination comma source. Okay, load space destination comma source. Okay, so this is the syntax. That means whatever that is present in the right side, okay, whatever the content that is present in the right side, it is going to be dumped into the left side. Okay, so destination means final value. That's what I have told. If I want to shift my house from Guntur to Tenali, the destination will be Tenali and the source point is from Guntur. Okay, from Guntur I need to take those luggage and I have to dump it in the Tenali. Okay, so here also LDR means it is a op code, operational code to perform the load operation. Okay, now so here RD is nothing but the destination. As per syntax, load space destination comma source. Okay, load space load space destination comma source. Here RD is the destination and this entire thing will be the source. Okay, here if you observe carefully, here the source is not given in a direct manner. Okay, if you observe here, the source is written as brackets, square brackets. Square brackets indicates, this is square brackets what are being showed by me indicates those are memory location. Whenever you encounter these kind of square brackets, that means those are nothing but the memory locations. That means those are nothing but the memory locations. Okay, so what does it mean? So what does it mean? Here the memory location is there. Okay, memory location means that is nothing but one address. How can I get the address? I can get the address by adding the rn with the offset value. By adding the rn with the offset value. So I think you may have a little bit of confusion on what I am saying. Okay, I will just resolve this with a simple example. See, what I am trying to say is I have to add rn value and the offset value. I will add the content of rn with the value of offset. All together I am going to get one value. For example, rn is equal to 1000h and offset OFFSC offset is equal to some 20h. Just imagine. Okay, then what I am going to do, I need to add these two values. So whenever I add these two values, I will get 1020h as an answer. Isn't it or not? So I will get 1020h because 1000 plus 20 is nothing but 1020. Isn't it or not? Okay. 1000 plus 20 is nothing but 1020. Okay, so this is the value what I am going to get. Okay, so now I will consider this 1020 as a memory location, and whatever the value that is present in this particular memory location, whatever this 1020 will be considered as a memory location. Okay, so it will be considered as a memory location. Okay, So whatever the value that is present in this particular 1020H, that will be loaded into the register RD. For example, in this particular memory location, if I have some 50, that 50 is going to be dumped into the register RD. Okay, so this is about the load operation. So once see load RD comma here, as we are discussing about the, these are the examples of which type ma memory mapped addressing modes. As we are discussing about the memory mapped addressing modes, here everything will deal with the memory. So whenever you encounter with these kind of square brackets, that indicates that this is a memory location. Okay, whatever the value will get in between these square brackets, that will be considered as the address of a particular memory location. Okay, so here I have given rn comma hash offset. Whenever you encounter with this hash, that is nothing but an immediate value. That is nothing but an immediate value. Now what we need to do, we need to add the contents of rn with the offset value. Okay, so that's what they have mentioned here. For example, in the register rn I have 1000 and the offset value is 20. These two are going to be added, then I will get 1020. So I will replace this entire thing, load content of rn comma offset, and I will place, this can be replaced like this. How can be replaced? RD, this will be replaced with the content of 1020H. Okay, so this will be replaced with content of 1020H. That means I will go to this particular 1020H memory location in the memory, and whatever the value that is present in that particular memory location, it is going to be transferred into the register RD. It is going to be loading it. So it is going to be transferred. Loading is nothing but here it is transferred. It is going to be transferred into the register RD. Okay, so that is the thing. Okay, next, for the further clarification, I have given a diagram also. Now we will move into the diagrammatical approach. One second. Yeah, here it is. I think store operation is there. Yeah, and the other one is store up. And the other one is store operation. Okay, now so the reverse of load is store operation. Okay, loading is nothing but taking from the memory location, taking that particular value from a memory location and placing it in a register is called load operation. The quite opposite phenomena is called store operation. In this particular store operation, what we are going to do is we are taking the value from a register and placing it in a memory location, that is called store operation. Okay, so here there are two types of opcodes or mnemonics for a store operation. One opcode or mnemonic is str and the other one is strb. Okay, so what is the meaning of str and what is the meaning of strb? That we need to discuss now. See here I have written str rd comma content of rn. Okay, the syntax of store is also see here str rd comma content of rn. What does it mean? See, I have clearly discussed previously that whenever you want to store the data, you need to store it in a memory location. Okay, here rn is the memory location, isn't it or not? How can you say I say it is a memory location? It is bounded with square brackets. Whenever you encounter these square brackets, okay, you need to come to a conclusion that whatever the value that is present in between the square brackets, it should be considered as a memory. It should be considered as a memory address or address of a memory. Okay, is it clear? Okay, so strRD comma content of rn. Okay, what is the thing that is going to happen is here I am going to store the values that is present in the register RD into the RN memory location. Okay, So I'm going to transfer or send the value, the values that are present in the RD register into RN. See, this may be a grammatically some mistakes may be there here. I think these braces are not necessary for RD; those are necessary for RN. Okay, I am transferring the value that is present in the RD register into the RN. Okay, so it is called store register. Okay, next here it transfers a word operand into the memory. See here, this is one of the example. str r0 comma content of r1 comma 12. Okay, here r1, for example, r1 is consider. For example, here consider r1 is equal to whatever it may be, capital R1 or small case R1, no, not about, no issue. Okay, capital R1 is equal to some 55h. Okay, and what they have given hash. Hash means it is an immediate value that need to be added to the existing value. So R1 is 55h and I need to add that particular R1 with a value of 12. Okay, so whenever I perform that particular operation, what is the thing that is going to happen? Here I need to add this 12h. Okay, so then I used to get what is the answer? 55 plus 12, it will be 67, isn't it? 67h. Okay, so this is the value what I am going to get. Okay, this is 67 will be considered as address, because this instruction I can replace this instruction with str r0 comma 67h. Okay, str r0 comma 67h. Okay, that means I have replaced the entire r1 comma hash 22 with which value? 67h. Is it or not? Yeah, okay. So now this 67h will be considered as an address, and whatever the value that is present, so the 67h will be considered as an address, and whatever the value that is present in an R0 register, it is going to be it is going to be dumped into the 67h. That means the value that is present in R0 register, it is going to be dumped into this particular 67h address. That is called a store operation. Okay, and we have one more operation called strb. So strb means store a byte. Instruction transfers the byte contained in the lower order end of RD. That means whenever I write strb, okay, it will not completely transfer the value that is present in RD into the RN, but it will transfer only one byte of RD. That means, for as we have discussed previously, what is the size of the registers here? What is the size of the registers here? Once I will explain previously. Here it specifies the 32-6-bit word. That means whatever we are discussing here, the word size is 32-bit. 32-bit means one byte is 8 bits. That means here one word, that means 32-bit. That means how many bytes? 4 bytes. How many bytes? 4 bytes. Whenever I write this instruction like str, okay, automatically the 32 bits are going to be transferred into the specified memory location. And here you should observe one thing, that entire 32 bits cannot be stored in the single memory location. Okay, in one memory location we can store only 8 bit of data. So for storing that particular 32 bits, we need 4 memory locations. 4 consecutive memory locations or sequential memory locations. Okay, those 4 sequential memory locations the computer will take care. Okay, whenever I specify one address, it will automatically allocate the remaining 3 addresses also, so that it can store the value. Okay, so str r0 comma r1 comma hash 12 means here we used to add these 2 values, and whatever the value that comes, okay, that will be in that memory location we are going to store this r1. But whenever I encode this strb instruction, okay, what is the thing that is going to happen here? strb means here we are going to store not the entire 32 bits but only 8 bits. Okay, 8 bits means 1 byte. That's what they have mentioned here. Na? It transfers the byte contained in the lower order end. That means I have 32 bits like this. For example, sorry. For example, I have 32 bits like 1 0 0 0 0 0 1 0 0 0 0 something like this. Okay, consider this is an 1 2 3 4. Okay, consider this entire as 32. It may not be, but what is the thing I want to say is, though this is 32-bit word, okay, whenever I write strp, it is going to transfer only the lower order 8 bits. That means starting from 0th bit to 8 bits. 1 2 3 4 5 6 7 8. Only these 8 bits, the lower order 8 bits are going to be transferred whenever I use the strp instruction. Rest of the bits are not going to be transferred. But whenever I use str, all the 32 bits are going to be transferred from the given register into a specified memory location. Okay, so and one more thing, one memory location cannot store all the 32 bits of value. Okay, for storing the entire 32 bits of value, it needs 4 memory locations, because one memory location we can store only 8 bit of data. Okay, so next I am going to the examples or diagrammatic part of you. Okay, just erase these things. Yeah. Here it is. Load and store is there now. So how, what is mean by that effective address? How can I get the effective address like this? Okay. Here I have written a store instruction. str r0 comma r1 has 12. This is the instruction what we have discussed previously. I have just told you orally and somewhat what I'll call by using a small example. Now you can understand the entire knowledge, or you can understand the entire concept by going through this diagrammatic view. See here, first of all, what is the thing I want to say is, whatever that is written in the square brackets, the entire thing is going considered to be a memory address. Okay, so whatever this entire thing answer that will be obtained after adding r1 with 12, the total will be considered as an address. So here, what is the first thing we need to do is, first of all, we need to add the contents that are present in r1 register with the value of 12, because hash indicates immediate value. So we need to add the value of 12 with the contents in the r1 register. First we need to do that one. Okay, so there is spotlight. Yeah, here it is. So see here r1. For example, let us assume that the value that is contained in r1 is 200. Then what is the thing I need to do? I need to add the contents of r1 with 12. That's what that is written in the instruction. So it is 200 and I am adding with 12. Then I need to get 212. But see, here we are going to for hexadecimal number system. Okay, here, okay, A means 10, B means 11, C means 12. Hexadecimal number system, you have good idea, na? So 200 plus 12 is not going to become 212 in hexadecimal number system. It is going to become 20C. Okay, so after adding these two values, I got an address called 20C. Okay, and this is a store instruction. So I have told previously that store instruction is nothing but whatever the value that is present in this register, it is going to be stored into the memory location, isn't it or not? Okay, storing means presenting some value into the memory location. So here the value that is present in the R0 register, it is going to be dumped into the address. Which address? The address that is formed by adding the R1 with 12. Why I am adding 12? Here in this example they have given 12. If here they may mention 15, I can add R1 with 15 and I am going to get one address. Okay, in that address I need to store this value of R0 register. So in this example, they have given R0 is equal to 0.5. That means they have given R0 is equal to 5. Okay, so then what is the thing I need to do? I need to store this value of 5. Where I need to store? In this particular address. What is the address I am going to get? I have R1 is equal to 200 and immediate value is 12. Whenever I add these two values, I am getting 200 plus 12. That means 212. In hexadecimal number system, 12 means C. So it is written 20C. If you have any problem, instead of writing 12 here, write 0C. No problem at all. Okay, na? Okay, this is 0C. So plus 200 plus 0C is nothing but 20C. Okay, so in this particular 20C, I am going to store the value of R0. R0 has a value of 5. So that particular 5 is being dumped here. So this is an example for store operation. I think you are very much clear now. Okay, now next I am moving to the next slide. Yeah, addressing modes in ARM. In ARM, we are having 3 addressing modes. ARM processor defines 3 addressing modes: pre-indexed addressing mode, pre-indexed write back mode, post-indexed mode. Pre means before, post after. So in pre-indexed also, one is simple pre-indexed mode, and other one is pre-indexed with write back mode, and the third one is post-indexed mode. So we are having these 3 addressing modes in our ARM. What is the full form of ARM? See, you should remember all these things once again. Okay. So now we are going to discuss about them. First one is pre-indexed mode. What does it mean? So if you yeah, in pre-indexed mode, what we are going to discuss is here the effective address is there. Na? So how can I get this effective address? Means here the effective address of the operand is the sum of 2 registers. It is the effective address is nothing but it is obtained by summing of base register and a offset value. By summing of base register and a offset value. Okay, now see this is the example. Okay, so how can I get this one? Here, this is an example for pre-indexing addressing mode. Here, LDR means load instruction R2, comma content of R1, comma hash 12. This can be taken an example for load instruction also, and this can be taken example for pre-indexing addressing mode also. Here, what is the thing? Whenever I encounter with LDR means load operation. Loading means taking something from a memory and placing it in a register. Isn't it or not? Taking something from a memory and placing it in a register. So here, if you observe these two things, if you observe here, see what is the memory here? This is the memory. Okay, and what is the register name? R2. That means what is the thing that should be happen here means I need to take the value that is present in this particular memory location and I need to dump it into the register R2. Okay, first of all I need to get a clarity about this value. Here R1 is a register and hash 12 means it is an immediate value. Now what is the thing I need to do? I need to add this R1 12 to the R1 register. I need to add this 12 to the R1 register. For example, here it is given as an example. For example, R1 has the value of 188. R1 is equal to 188. Now what I am doing? I am adding this 12. So 188 plus 12 means 200. See, don't ask me, sir, why you have written here it is hexadecimal like that. Just assume that it is in decimal format. Okay. So 188 plus 12 means it is 200. Now what I need to do? I need to take the value from this memory location. So total this value is 200. Then I will go to the memory and I will search where that particular 200 address is. Here the 200 address. Okay. In this particular 200 address, I have a value of 27. Okay. So I will take this particular 27 and I will dump it into the register called R2. I will dump it into the register called R2. Okay. Okay.